In our previous lesson, we learned how to multiply monomials, which are polynomials with just one term. Today, we will continue practicing multiplication, but we will be multiplying monomials with binomials, which is just a polynomial with two terms. So in this example, we have 6h to the second power, which is our monomial, multiplied by h minus 7, which is our binomial since it has two terms of h and negative 7. Now I know that I'm multiplying these two things because, as you can see, there is nothing in between this term of 6h to the second and this term of h minus 7. There's no other operation happening between these two things, and when we have two things next to each other in this way, only separated by parentheses, we know that we are dealing with multiplication. So this is telling me take 6h squared and multiply it by h minus 7. So notice that I'm going to be multiplying the whole entire 6h squared because 6h squared is just one term. Again, there's nothing in between these two things. So this is one term, and that whole entire term is being multiplied by h minus 7. Now, h and negative 7 are not like terms, right? H has a variable, 7 does not, which means I can't just simply combine those two things and then multiply by 6h squared. Instead, I have to use my distributive property to distribute the 6h squared like we would have done in our simpler expressions. So let's see how we do that. The first thing that I'm going to do before I start multiplying anything out is that I'm going to first add my ones to the variables that don't show their coefficients, and I'm also going to add the ones to any variable that doesn't show their exponents. So in this case, if I rewrite this, I'm going to have 6h to the second power times 1h to the first power minus 7. Just like with the coefficients, anytime you see a variable that doesn't show an exponent, there's always an exponent of 1 there. So now I can start going ahead and multiplying these two polynomials out. So first I'm going to take this 6h squared, the whole entire thing once again, and I'm going to distribute it to this 1h to the first power. So I'm going to have 6h squared times 1h to the first power. Okay, and then I'm going to take that same term, that 6h squared, and I'm going to distribute it now to this negative 7 that we have over here. So we have 6h to the second power times negative 7. So essentially we're still doing the same thing that we did before with distributive property, except that now we have a little bit more variables and more terms that we have to consider. So now that I've distributed the 6h squared to both of these terms that are inside of this parentheses, I can start multiplying things out. Now remember that when we're multiplying monomials like 6h to the second power and 1h to the first power, we can multiply coefficients with coefficients and letters with their common letters. So here we have 6 times positive 1, which gives me a positive 6. And I have h squared times h to the first power, which gives me h to the third power. And just as a review from our first multiplication lesson, h squared times h to the first, this one, that means I'm multiplying two h's, and this means I'm multiplying one h. So in total, I'm multiplying three h's over here. So that's h to the third power. Now on my second part over here, I have 6, which I'm going to be multiplying with negative 7. So 6 times negative 7 is a negative 42. And then I have this h squared, but there's no letter, there's no h that I can multiply this with on the negative 7 term, which means I'm just simply going to bring that down next to the negative 42 that we have here. So then if I check, h to the third has an exponent of 3, and h to the second has an exponent of 2, which means I can no longer combine these things. I can't add anything here. These two things are from two different families. So my final answer here is just simply 6h to the third power minus 42h to the second power. All we've done is take what's outside of the parentheses, distribute it to the two things that we have inside of our parentheses, and then when we multiply coefficients with coefficients and variables with variables. If there's nothing for you to multiply a variable with, then you just simply bring it down. Now in this example, we have find the product of 3x and x squared plus 2x minus 1. So here they're giving us the problem in the form of a word problem. Now, if you remember from our lessons with other operations like addition and subtraction, we have to identify our keyword here that tells us the operation. In this case, the keyword that we have here is the keyword of product. And we reviewed in our previous lessons that product means that we are multiplying. Product is a keyword for multiplication. So previously we learned that if we saw something like sum or addition, then I'm going to have two things that I'm adding. If I had something like subtraction, then I would have two things that I'm subtracting. But if I have something that I'm multiplying or two things that I'm finding the product of, then I'm simply going to just put two parentheses right next to each other, nothing in between, to show that those two things are being multiplied with one another. So in this case, I have the product of 3x and x squared plus 2x minus 1. So I have 3x times x squared plus 2x minus 1. And now we can do the exact same thing that we did in our previous example. The only difference here is that I'm multiplying a monomial with a trinomial, which is just a polynomial with three terms like we have here, but nothing about what we do changes. We're just going to be distributing to more than two things. Before I start distributing, I'm just going to go ahead and add the ones as my coefficient, and we'll add the ones to my exponents as I see them here. And now I can go ahead and start distributing. So I have 3x to the first power times 1x squared, so 3x to the first times 1x squared. Then I have 3x to the first power times positive 2x to the first, so 3x to the first times 2x to the first. And then last but not least, I have 3x to the first times this negative 1 here. And then I can go ahead and just multiply my monomials out separately. So I have 3 times 1, which is 3. And I have x to the first times x to the second, which is just x to the third power. Again, I'm just putting together all the x's that I'm multiplying in total. Then I have 3 times 2, which is positive 6. And x to the first times x to the first is x to the second power, because again, I'm multiplying two x's. Last but not least, I have 3 times negative 1, which is negative 3. And there's nothing for me to multiply this x to the first with, so I'm just simply going to rewrite it right next to my negative 3. Right next to my negative 3. And now again, all these three terms have different last names. This is x to the third and x to the second and x to the first. These are all different, which means I can't combine these three things. So I'm simply going to just rewrite them next to each other for my final answer. So I have 3x to the third plus 6x squared minus 3x to the first power as my final answer. And remember that whatever polynomial we get at the end as our product is always equivalent to what we had in the original setup.